Awesome. Welcome back here to the AWS Loft in San Francisco here today. For those of you here in the room, thanks for continuing to stay with us and joining us here in person. All this week, we've been covering recaps of reInvent launches and kind of updates into the technology space that we have here at AWS. Today's day is focused entirely on the serverless platform of services that we have, or portfolio, I should say, of products. And so far, we've had 3 different sessions here today. We have covered a view into Lambda and serverless applications, spent a little bit of time talking about some of our tooling, including the AWS SAM template engine and the SAM CLI. And then just before this, we covered the Lambda layers and runtime API announcements from reInvent, 2 really big key critical features in AWS Lambda that we're really excited that we were able to announce. We're continuing on here today in this next hour talking about APIs, the API Gateway. And then again, at the next hour, we will finish up with diving a little bit deep into AWS Step Functions. If you're just joining us again, my name is Chris Munns. I am currently a Principal Developer Advocate for Serverless here at AWS, based in our New York City office. Been in AWS for a little over 6.5 years across a couple different roles, but come primarily from a startup background, worked for a number of startups in the New York City area, primarily in what would be considered ops or DevOps or sysadmin type roles. So why are we here again overall today? So again, today is primarily about serverless, but this session in particular is about APIs and the power of APIs. One thing that I like to do, and that I've spent a lot of time over the last couple of years doing, is talking about how we internally at Amazon have shaped and done product development for quite some time. If we go back historically and we look at Amazon, first launched back in 1994, and grown obviously since then, so we're a 20 and change year old company. If you used Amazon.com, the retail site, back between 1994 and 2001, opened up your web browser, went to Amazon.com, went to the home page, went up to the search bar, searched for whatever product you might be looking for at that point in time, landed on a search results page, clicked on a listing, looked at a bunch of different listings, read all the information, added it to a cart, went through the checkout flow, and eventually checked out. All of that happened as part of a large monolithic application. And actually, we did a lot of things back then in Perl. We had a lot of large monolithic databases. And so what we found as we came into 2001 was that this was kind of holding back our ability to move faster and to grow our platform and be able to support new capabilities and features. And so we spent some time thinking about how to reshape basically the flow that we had for how we did product development in terms of how we had our teams shaped, how we built this monolithic application, and then the delivery pipeline that allowed us to get through deploying out these new features. And I like to say that back when we had the monolith, what happened as we looked to add new features and capabilities is that it wasn't akin to too many cooks in the same kitchen. It was too many cooks stirring the same pot. Everyone adding their own ingredients, taking a sip, and realizing that the gulag didn't taste too good. And so it was back in about 2001 that we started to go through really dramatic transition through how we were shaped as an organization. From the people side, we moved from these large monolithic teams to something that we now call a 2-pizza team model, kind of a small cell-based mini kind of a team inside of the larger whole. We broke down the application into microservices, and now these teams are highly parallelized, delivering their own components. In terms of how we think about our architecture, again, we do what today is considered architecturally microservices. So we went from that one big monolith into what you see here, which is actually an image from about circa 2008, 2009, all of the services that were inside Amazon. So this kind of Death Star-ish looking diagram, as I like to describe it here, again, represents all the various different capabilities and services and stuff that you see now. Again, but now almost a decade ago. So the lines of connectivity represent dependencies across these, so which services were dependent on each other. And so in the middle, there are kind of common services like authentication and authorization and other things that were used across other services. Now, each of these little boxes basically represents something that has an API. And services were basically shaped that they would only connect to other services' APIs to get information. And you could only share your own services information via an API. So it's very much ingrained in the culture of how we think about software. Now, primarily, these connect over HTTPS. There are some other means for transferring information today, things like services like SNS or queues or other streaming services. But by and large, HTTPS RESTful APIs is what we've built. And we consider these to be largely black box from each other. So if I'm building a service and you're consuming it, all you really get to know is my service's API spec, what performance you should expect, and what my API does. You don't really get to know what language it's written in, what operating system it runs in, what databases I use, any of that kind of stuff. Another way to think about this is that when we first launched AWS S3, so Simple Storage Service, one of the first services we had here at AWS, I believe back in 2006. When we first launched that product, it had 8 separate microservices that made up what it is. And now this is an image here from reInvent, where one of the leaders of S3 got up on stage and talked about the history of the product. And so started at 8 back in 2006. And when we jump forward to 2018, S3 is actually more than 235 microservices. Just one product, 235 microservices. Now, S3 happens to be a product that has a whole lot of capabilities, does a whole lot of different things now than it first did when we launched it 12 years prior. But again, that's kind of the model that we have. As we expand, we add more microservices. Sometimes we divide services into other ones, all API-driven. So APIs are kind of the name of the game for how we build technology. And so this leads us to some pretty interesting stats. Today we have thousands of these 2 pizza teams building this microservices architecture, practicing continuous delivery with multiple environments. We talked about things like dev, staging, and prod before. And what it means is that in 2016, we actually did a little more than 60 million deployments that year. So that's a lot of deployments. Again, API-based applications. Now, this is just us. There's other ways to look at it. There's a really awesome book out there called Building Microservices by a gentleman named Sam Newman. It's kind of considered one of the authoritative sources on this concept of microservices. And in relating this to APIs, Mark Andreessen, who's a famous VC here out in the Valley, has a phrase that software is eating the world. He said this a number of years ago. There was kind of a retort from a gentleman named Dr. Steve Wilmot, who's currently at Red Hat and represents the API space from them, who said, well, it's APIs that are eating software. Right? The software that people are designing today, by and large, is API-driven. So here's your small little biology lesson for the day. Does anyone know what honeybees have to do with building microservices? Anybody? Nobody? Good. So I can teach you something non-technical today. So if you went into your favorite web browser and you searched for APIs, which you might think of as APIs, it could also be Apis, which is the genus for honeybees. And so you might occasionally get lost on the wrong page looking for information about APIs, or you might be really interested in honeybees. But so I don't know for sure that Sam and the folks at O'Reilly put honeybees on the cover as part of kind of a tongue-in-cheek joke. I think that they did, but there's a relation that you have between the two of those. Anyway, a little fun fact. More about APIs, so again, they show up all over the place, right? Many of us are wearing or carrying a device that are talking to APIs all day long. Again, whether it be the phones in our pockets, the things on our wrists, the cars that you might be driving if you have one, the devices that are around your home, increasingly APIs are everywhere. In terms of companies that have been very disruptive in various different industries, they have been largely around building APIs. If we talk about Airbnb, headquarters just down the street here, they've been building APIs for the last 10 plus years. Uber, Square, Slack, all API-driven organizations and how they build their architectures and their technology. So APIs, super critical, super important, the way that we think about modern software today and getting away from these concepts of the monolith. So let's talk about building your APIs. And I'm going to assume here that most people here already have a fundamental basic understanding of what APIs are and how they work. But let's kind of take it from a low level and then go a little bit deeper. All right, the basic technology stack for an API is typically you've got a client, the internet or a network, some sort of API server, some sort of backend, and then databases, data stores, et cetera, that you might be talking to. Now, when it comes to things like APIs, there's basic ways that you can do them, and then there's the ways that you have to do it if you want to expose your API to millions of customers, similarly to what we do and many other companies that are out there. And even internally, when you're managing APIs, there's a number of things that you struggle with. Things like managing multiple versions, environments, so stages in our terminology. If you need to expose access to other developers, so companies, for example, like Stripe here have an API exposed to developers that's incredibly popular. Access authorization can be a challenge, things like traffic spikes, dealing with management overhead of having to maintain this layer. And so this is typically where people think about having some sort of API gateway. And so again, I mentioned this earlier today, API gateways as a concept is not something that we invented here at AWS. There are many different API gateways in the industry. There are hosted APIs, there are enterprise APIs you can buy, there are open API gateways that you can find. But one thing that I've been encouraging companies for half a decade now is find an API gateway product and centralize on it. Get everyone in the organization use the same API gateway, standardize on it for public, private, whatever it might be, find an API gateway. Happen to be slightly opinionated. I think that we have a pretty amazing API gateway product here at AWS. And it's got a lot of capabilities. And I'm not going to read through the laundry list of these here, but just to cherry pick a couple, ability to get out API keys for developers, being able to do things like throttling and modeling at usage tiers, SDK generation, that's a pretty cool one, DDoS protection. There's a whole lot of stuff that you can do with Amazon's API gateway. It also meets the key criteria for a serverless product. So you don't pay for it when it's not in use. It automatically scales. It's automatically high available. There's no servers you have to set up or manage for API gateway. And if you've been here in the room for most of the day, or if you've been following along on Twitch, you've seen us briefly demo some capabilities of API gateway just really quickly. Now, API gateway has been around for about 3.5 years now, has a number of capabilities to it. It's a really robust piece of technology or service, I should say. And so we've got different ways of exposing APIs out to your services or your clients, and then different ways that those APIs can be powered. And we're going to go into all of that stuff right here. Now, I mentioned this very, very early today, but just coming back to it again, we did just announce a couple weeks ago support for WebSockets and APIs. Now, WebSockets represent an interesting shift in the API space in building near real-time API interaction where from the back end of the API, you want to push a message out to the consumers of that API. So this can allow for really interesting things, whether it be mobile apps or dashboards or IoT or chatbots and stuff like that. Now, WebSockets as a technology itself is not new, but one of the challenges in the space of serverless has been that traditionally, the compute tier that handles interfacing with your data and your customers has to store some state about which clients there are involved in the WebSocket connection. There's an active client, and there's a state that has to get managed. Now, this has resulted in people needing to run very outsized compute tiers because they have to track all that state, even if messages aren't being pushed. And so this can be a place where WebSocket APIs can become very expensive. One of the challenges we've had in the serverless space is that serverless workloads by default out of the bag are just kind of ephemeral. Lambda functions go away. They don't maintain state. API gateway is kind of a transitory proxy at the end of the day. So this is pretty new and pretty different and pretty exciting because basically what happens here is that API gateway manages that state for you. It tracks the connections and what clients are around. And then any backend can be used for your WebSockets API. And again, with this, you're not paying for servers. You're only paying for what you use with API gateway. Now, in terms of what goes behind API gateway, again, whether you're doing WebSockets or just normal REST-based HTTP APIs, could be almost any compute service you could think of. So you could certainly put EC2 or one of the load balancer products that we have here at AWS behind it. You could put a container behind it. And this could be a container running from one of our services, or if you're running Kubernetes yourself or something else. And then obviously Lambda, which we've shown a couple times here today. Now, when deploying a microservice with EC2, it's pretty straightforward. You're typically going to have EC2 configured in an auto-scaling group. Maybe, maybe not, but that's general best practice. And then you have some sort of a load balancer. So Elastic Load Balancer, Application Load Balancer, NLB, or Network Load Balancer, depending on what your need is from that load balancing tier. You'd put that behind API Gateway, expose out your web interface from those services, and then API Gateway can handle the outbound interface to your API. With ECS or EKS or Fargate or Kubernetes or any container workload, your options are either that you run something like Nginx locally that represents out a service, or you put those behind a load balancer as well. And in this case, API Gateway then is representing back through those to the container-based workload that you have, and scaling and all of that is handled either by the service or by something like auto-scaling behind the scenes. Now, we've already kind of covered Lambda earlier today. And so again, what happens with a Lambda-based backend is that API Gateway calls the Lambda API to invoke it. You never need to think about scaling it. You never need to think about load balancers or anything like that. API Gateway will just automatically call the Lambda API for invocation of your function. And so this represents, again, a number of different architectures. Again, with the API Gateway in Lambda, it's pretty straightforward. It just invokes the Lambda API. But you can actually put API Gateway in front of a number of different things. So we can put it in front of step functions, which we're going to end today talking about step functions. So this can be really useful if you have an asynchronous API that needs to kick off some sort of a workflow behind the scenes. You can also, and I think this is one of the coolest things you do with API Gateway that people don't know about, is put API Gateway in front of almost any AWS service that you could think of. And so one thing that we see people do is have, say, a mobile application that needs to just get data back and forth from a database, like RDS, or like DynamoDB. And what you could do here with DynamoDB is just map the DynamoDB API behind an API gateway, expose out any sort of API from the API gateway that you have there, and do all of your logic for how you handle creates, reads, updates, and deletes in your mobile application. So instead of even having a compute tier, you can just directly expose DynamoDB up to your application. But you can use things like the API keys the API gateway provides, usage tiers, throttling, caching of the information in the API gateway, again, without having to manage a compute tier. So that's pretty cool. You can put it in front of things like Kinesis so that you can expose Kinesis out to things like mobile applications. So if you wanted to collect, say, session information or tracking information about that from this mobile device, I can have it talk basically directly to Kinesis through API Gateway without having to embed in my app, say, AWS credentials. So just a couple of examples that you can do there. You could also put API Gateway in front of resources that exist inside of a private data center, for example, via a direct connect to your AWS account or your AWS VPC, Virtual Private Cloud. You could expose private resources inside your data center. You could also put API Gateway in front of any public HTTP endpoint. If you have an app running in Heroku, you can put API Gateway in front of it. Have an app running in another cloud provider, you could put API Gateway in front of it. So it can be backed by anything publicly or basically privately HTTP serving. Now you have 3 different types of endpoints to choose from, and they represent all sorts of different needs that you might have. One is edge optimized. So this was the first that we first launched the API Gateway with, and this is where we basically will give you a CloudFront, which is our CDN service, distribution. So CloudFront has 100 plus points of presence around the globe. I think we're almost about 160 or so points of presence, if I can remember the number right. And what this means is that if you have users that are connecting from the web, again, browser or mobile-based, you can make use of the acceleration of having a CDN service in front of that API. You might also have an API that needs to be exposed just inside of a region, or one that you want to bring your own CDN configuration to, and then you can use a regional API. And so if you are using another CDN service like Fastly or Akamai or something like that, you could put that in front of your regional hosted API. And then lastly, private APIs. So this is something we launched just last summer. These are APIs that exist only inside of your virtual private cloud. And so this is for things like internal microservices that, going back to the diagram I had of S3 being 235 microservices, almost all of those are private into the infrastructure and not consumed externally by customers. And so, again, supporting that growth of the microservices world that we see. So sticking with the theme of today, let's again say that we have got API Gateway, we're going to have Lambda as our backend tier, and then whatever database we might have behind the scenes. Now, I mentioned this earlier, but just to rehash this, one really, really common architectural pattern that we see that's growing rapidly today is this concept of a serverless web application, where the entire stack can be serverless, pay for what you use, no permanent infrastructure, no servers that you run. And again, this is a situation where you're using typically some sort of modern JavaScript framework to represent your web application, whether it be something like React or Vue or Angular or any of those. That would get stored in S3 with your CSS and other static content and served out with S3 as a web server. Now, that could optionally be fronted by CloudFront. And then all of your business logic could be in API Gateway and Lambda. And again, with this, you have automatic scale, just pay for what you use, high availability, no servers to manage. So pretty exciting and something that we see kind of shifting the industry in this way. So let's talk about security. So going back to that diagram that we have of all of the various capabilities of API Gateway, Where would you imagine from here that you could add security? Well, the answer is actually everywhere. There's different ways that you can add security to every single bit of this stack. Right? We could have security at the client side, so your customers need to log in with a username and password in order to access your backend. You could also have specific API keys that only exist in the mobile device that enable to access the backend. Typically, you're going to have things like encryption on the wire, so API Gateway is going to use SSL for the APIs. From your API Gateway to your backend, in the case of it being Lambda, it's going to use IAM permissions to say whether or not you can talk to that Lambda function. Or if it was other backends, you could do things like be able to authenticate that backend. And then from your Lambda function to your database, which we've seen earlier today, you have the function policy, which says what can this function do and what can it talk to. So we can add security in all these various places. But in talking just about API Gateway, we have a couple different security mechanisms that exist just at the API level. So we see here we have IAM permissions. So this is basically the ability to say that IAM or AWS credentials can be used to access an API and interface with it. We have a Lambda custom authorizer. So this is where you would write a Lambda function to interface with some sort of custom logic. This could be a user management system that you run. This could be a Lambda function that interfaces with something like Auth0 or any other sort of identity provider that you might be working with. We have something called Cognito user pools. I'll talk a little bit more about here in a moment, which is a completely managed user management system. And then we have a concept called resource policies. What's unique about resource policies, it ties into things like private API endpoints. You could say all of the services in my VPC can talk to this, or just certain subnets, or just certain AWS accounts. And it's kind of a wider way of scoping who and what can access your API gateway. Now, Lambda custom authorizers are pretty popular. We see this for people that have an existing user management service where they are already handling things like API keys or some sort of other credential that they give to their customers. And so you can create a Lambda function that basically interprets the success or failure of accepting those credentials and then uses a token to tell the API gateway, this is good or not, more or less, a simplified version of it. I gave the example earlier of how we had a request for basic HTTP auth for API Gateway. It's not something built into it. And so the lead PM for API Gateway actually went and built one and hacked it together and published it in the serverless application repository. And so you can have everything from basic username and password up through more sophisticated tokens or security keys. Lambda custom authorizers basically support any of that. Now, if you don't want to manage your own user system, which is something that I would never encourage anyone to do, there are options like Cognito user pools. And so what user pools do is give you a completely managed user credential and information management system. You can have everything basically handled for you from sign up and sign in workflows, being able to do things like have multi-factor, whether it be a token or an SMS, email verification, password resets. It can also do things like detect if people are trying to log into an account, like trying to brute force into it and react to it. There's a whole lot of capabilities in Cognito user pools. We could probably spend a whole hour talking about that. But in general, this is one of those things that as a developer, running your own user management system is not providing value to your business. And so I'd encourage you to look at the various providers that are out there of this technology versus building this stuff yourself. So let's talk a little bit more about what goes into deploying APIs. So we've seen today some of the really basic examples of what can be done with serverless APIs and using SAM, for example, to deploy them. But it's important to note that we have a lot of customers that aren't using Lambda behind API Gateway. They're using things like EC2 or ECS or other technologies. And so it's important to know how to deploy APIs without SAM. I've mentioned a little bit earlier, there's this concept of stages in APIs. You can use these for things like lifecycle management, so having dev, test, prod, or alpha, beta, gamma. A side story, when I worked at Etsy, we had a strong kind of back and forth about what we should call the pre-production environment. And we argued about whether it should be called pre-prod or staging or whatever it might be. And instead, we settled on Princess. So we called our non-production environment Princess, and you deployed to Princess before you deployed to prod, and it was just because we realized the term didn't matter. But in this case, you could have an API gateway for Princess and an API gateway stage for prod and do that. So whatever you want to call it, you can call it that, but essentially think of them as separated out environments that represent the same API definition and spec over time. Now these have API gateway stage variables that align with that stage that represent effectively key value pairs that can be passed down that customize the functionality of that stage at whatever stage it is. So for dev, I could have certain values passed down. For prod, I could have certain values passed down. And again, we gave the example of how you can use this for doing traffic shifting in Lambda and or not, at least, and be able to map these stage variables back to things like Lambda aliases and versions, and be able to do things like true software lifecycle promotion processes and fun stuff like that. But API Gateway's got a couple capabilities that make it powerful beyond just what you can do with interfacing, for example, with Lambda. And so API Gateway does have its own concept of Canary support. We talked about canaries with SAM and safe deployments earlier here today. But with API Gateway, you can do a very similar thing where you can shift a certain % of traffic to your customers of your API. And so this can be really useful for a number of different things. A, deploying from version 1 to version 2 of your application, and you want to push out just a small amount of traffic, you could do that. But what's really interesting about API Gateway, or one interesting thing I should say about API Gateway, is that we see customers using this to do a lot more creative and interesting things. Let's say that today you have an API that's running in a traditional monolithic sense, or you have an API that's running on virtual servers, running inside of AWS or any place else. We'll see customers use API Gateway as a mechanism for migration. So put an API Gateway in front of your API that is monolithic and running inside of virtual machines. And then basically use canaries to shift portions of traffic out to a new backend. And you could do this on a method-by-method basis. You could take a single API call from the entirety of your API and point it at Lambda and test it for a period of time that you define. Indefinitely, a couple hours, a couple minutes, a couple days, and then decide whether you want to shift traffic one way or the other. I've seen people be able to use this to take APIs and move them from on-premises up to the cloud. So taking them from their data center, moving them up to an AWS environment. And so again, you can get really fine-grained down to the method level, shifting this traffic, or you can do an entire API, or you can do, again, various different parts of it. Again, pretty straightforward. I have version 1 of my API. I'd like to deploy version 2. So I configure up and deploy version 2 on API Gateway. And I don't do anything with my API clients. They're going to a certain backend, and that's just going to be there behind the scenes. Or the API Gateway definition stays the same from like a URL perspective. And then whatever's going on in the backend is separate and different, and that's fine. And now I could sit here and, again, we generate different logs and metrics for the different versions of your API. And so I can go and compare and contrast against those. And then if things don't look good, I can manually roll that back. If they do look good, then I can roll it forward and move on to V2. And again, my clients don't ever have to know what's shifting as part of this. So really great for doing migrations. I've seen customers want to do it for trying out different languages. Hey, we've traditionally written this API in Java. We'd like to explore Go. On a method-by-method basis, you can move to Go and change out the backends. And so, again, harder to do without an API Gateway product. So how can we do other things, right? How can we get our clients to connect to our API? Now, it's trivial to just publish an API definition and tell your developer customers, if you produce an external API or even internally to other teams, here's an API spec, go get them. But one thing that I really like is when companies actually produce client SDKs. And so with the API Gateway, we can create client SDKs of our API. So assume that I define my API in something like Swagger, now called OpenAPI, which is a template-driven way for defining APIs, kind of an industry standard. So I define my API, deploy it up to API Gateway. I've got version 1.1. I can actually say, hey, API Gateway, give me an SDK, or give me code in Node.js that represents my APIs. And it's going to give you a zip file that has all of the code that you need in Node.js for basically all of the functions that are inside of your API. And I can take that and I can wrap it up as an NPM. I could put that in some sort of NPM repo, publicly or privately, or I could put it in a Lambda layer, for example. And then I could tell my customers, externally or internally, hey, here's version 1.1 Node.js client for my API. Go and consume that. And they consume that code base, it points back at the API. They don't have to know my API spec. They don't have to write a whole lot of code. I'm giving them basically the keys to access this data. Over time, I might decide that I'm going to release the next version of my API. And so I just go through the same process. New Swagger document, upload it up to API Gateway, generate a new client SDK, wrap it up as an NPM or whatever, or a layer, publish it, and away you go. And so it's pretty straightforward to do this, but it's pretty powerful. And I think that if you're building APIs that are meant to be consumed by not your organization or even yourself, generating an SDK will save you some time in being able to do that. Now, the SDKs that API Gateway generates for you follow best practices that we have at AWS. So by default, they will do things like back off and retry if you so configure it. The code is there, and so it's an interesting learning tool as well, I would say. Now, one thing that we've recently done, this happened right before reInvent, but we continue to put more capabilities into it, is we relaunched the API Gateway Developer Portal. And so this is something that you can use to expose to the customers of your API, publicly or privately. And we've actually launched this as a serverless application. So I am going to show that to you now. So I'm going to come back in here to the Lambda console and go to functions, create function, serverless app repo. Let's see if I type in, oops. Oh, I missed an R there. I'm trying to remember the right search phrase for it here. Here. Easiest way to find it is Amazon API Gateway, Developer Portal. And we'll find the what's new. We'll just go to the documentation. That's right. And in the documentation here, it will link to the name for this. 1 second here. Here we go. Cool. So this is the application detail here in, that's right, it doesn't have the word developer in the title, just dev portal. Sorry. So this is the application here in the serverless app repo. Again, I can go in here and just click deploy, and it'll take me back into the console. And I can find out all sorts of aspects about this. It has a bunch of application settings. It's got a README file that walks directly through all of it. And what you end up getting after this is deployed is a really sophisticated serverless application. It's actually a really great example of a full-fledged serverless application that has 31 resources that come out of it. API Gateway definition, a whole bunch of Lambda functions, Cognito user pools, and S3 buckets. And so it lives in an S3 bucket. And so I think if I'm trying to remember where, 1 second here. If I come and get the outputs for it, that's right. This is in the CloudFormation console because it launches via SAM. That's right. Sorry, I broke this earlier. Anyway, you can come and find this here and launch it pretty trivially. Again, linked out of the docs. But the dev portal is really powerful, so you can go through and publish an API for it. We're working on a lot of other capabilities, so it has full documentation. It has things like keys that you can generate for developer customers. And so I would definitely encourage you to take a look at the developer portal. We're going to be adding a whole lot more functionality to this real soon. The team's cranking away on it. And so this is something that is pretty new in terms of API Gateway. OK. A couple other things here about API Gateway. I always like to say that you can't move fast if you're not measuring what you're doing. As a former operations person, oh, excuse me real quick here. I had a thing that lit up on my laptop. As a former operations, DevOps-ish kind of person, I've spent a lot of time building out metrics, logging, and monitoring systems. I am really happy that this stuff is all built into the serverless ecosystem today. And so inside of both API Gateway and Lambda, we capture a number of metrics for you. They're just generally made available and can be consumed. Inside of Lambda code, you can also create custom metrics using the CloudWatch metrics API call for put metric data. In terms of logging, it's the same way. So API Gateway actually has a number of capabilities for capturing log data for you. You can specify the level of the logging, so error or info, or both of them. You can also capture full body request content, though I would caution you that this could be a lot of data to store for a really busy API, and you do pay for logs. So you want to turn that on when you're doing debugging, but potentially not all of the time. And this can be configured at this stage or per method, so really fine-grained. If you want to, say, do what I mentioned before about transitioning a single API method to a new backend, you can specifically turn on full capture for that and be able to get that information. Lambda similarly has access to logging as well, captures anything that's just output. And then you can do things in CloudWatch logs, such as what's called log pivots, which allows you to generate essentially a regex or a regular expression that can pull data out of your log lines and generate metrics and alarms based on that, and then dive into those. And the other thing is that it's really easy to take those logs and then put them into, and I'm sorry, this should say Elasticsearch or S3, and then look at them with things like Kibana or Athena or QuickSight. Now, integrated into API Gateway, and I think it's really pertinent for API Gateway, is something called AWS X-Ray. And so AWS X-Ray allows you to do profiling and tracing of calls in a distributed system. So, thinking about that 235 services that make up S3, knowing how traffic and how requests are flowing through some number of those is really important. And so with X-Ray, which is supported in API Gateway, it's supported in Lambda, a number of other AWS services, we actually can see a map of what the request flow looks like from a service call perspective across different services. And so this can be really useful for understanding where there might be failures or issues. You can see histograms of performance and be able to go back and look at what failed when and potentially why. And so it shows you this cool little graphic that you see here, this service map. It also gives you a waterfall view of calls that were made inside of a flow. So if I had an API Gateway-based example here, you would see the first service being API Gateway that talks to a Lambda function that maybe talks to a database, and I can capture that full flow of calls and see how it's performed over time. Now, I mentioned this pretty briefly before, again, with API Gateway, there are lots of people that are using it without Lambda. It is not just tied to Lambda. And for APIs and API definitions in general, there was a tool called Swagger that's become very popular in the industry. It, in version 3, renamed itself to the Open API Specification, or OAS for short. And you can use this to define out your APIs. Now, when you use SAM to set up a serverless application, we actually generate behind the scenes Swagger text for you in CloudFormation, because you can actually embed Swagger into CloudFormation. But you can create this yourself to define your APIs, and there are a number of testing tools, monitoring tools, security tools that will take a Swagger document and do things like generate a test suite, generate monitoring, generate security tests or validation. And so Swagger/Open API is really great. It's standard specification for this. And so I encourage you to take a look at this just for interfacing with a third-party world that's out there. So let's go, again, real quick here and pop out and hop into the API Gateway console. We spent a lot of time here today in the Lambda console. But here in the API Gateway console, there are all sorts of things that you can do. So we can see here I have a whole lot of different APIs defined. Earlier before when we were talking about layers in runtime, I showed you that I had a PHP API, and it was a really basic thing. It has a single resource, just / of my URL, and then it supports any call that I want to make to it in terms of HTTP calls, so puts, gets, deletes, posts, etc. Now we've got other APIs that are a bit more sophisticated. Let me go find something here. Well, for example, we have our magic 8-ball, which had the route for 8-ball as well as an any. Let me see if I can find a slightly meatier example. I have another API here, but let's actually dive in and look at how these are configured. So again, this is the resource. I just have a single call that I support here for /. In terms of stages, I have a prod stage and a stage that's just called stage. And I can go and dive into that if I want to set for specific types of HTTP calls, how I should respond and what I should do. In this case, it just inherits it from the overall stage. At the overall stage level, this is where I can go in and set things like cache settings. I could change the way that logging and tracing happens. I could set up stage variables. I could do SDK generation. I could do document history, set up canaries, all sorts of stuff like that. I could also come in and do things like shape gateway responses. So let's say that you were putting an API gateway in front of a legacy API, and that legacy API doesn't do the best things. Sometimes you may actually want a service to respond with a 200 code and an error message versus a 400 code, which would potentially cause a failure in a client. Just as an example, so you can come in, you can configure all of the HTTP requests and responses. You can model different types of mappings for things. I have a good example of that here. And then obviously there's a dashboard in here for seeing what's going on in this API. So lots of information that you can get from this, lots of things that you can set and configure inside of this. And so a valuable place to become familiar with. Cool. So just wrapping up, again, we've talked about a number of different aspects around APIs already here today, but the importance of APIs in the industry and how people are building software, I think is still even kind of in the early days. There's still companies that I think aren't paying attention to the importance of how to think about building APIs. But again, the devices we wear, the technologies we interface with, the companies that have shaped the various different industries that are out there are building APIs, and there's a good chance that it's something you'll have to become familiar with. Benefits of things like API Gateway in terms of there not being infrastructure that you have to manage, automatic scale, paying for the value that you get for it, so not paying for idle. Obviously incredibly important. Lots of different integrations for authentication and authorization. Again, the various capabilities about supporting different types of how the API is exposed, edge, regional, and private, different backends, so EC2, containers, Lambda, anything out there on the internet. It means that you've got a lot of different things that you can do with API Gateway. Just like I was with a lot of the other stuff we talked about here today, you can find out this and more about the API Gateway and building APIs on aws.amazon.com/serverless. Again, if you look at the white bar up there, you'll find links to things like the application repository, developer tools, resources, various partners and stuff that exist. And so like in the resources, for example, you'll find all sorts of getting started stuff for building APIs and managing APIs. So I encourage you to check that out. Again, my name is Chris Munns. You can find me at munns@amazon.com or at Chris Munns on Twitter. We're not done here today. We're going to start up here at 3:15 here Pacific time, talking about step functions. But for now, we're going to take a quick little break and come back to that. Thank you for everyone who's joined us here remotely on Twitch. Again, we'll be right back real soon here with the rest of our day. And for those of you here physically in the loft, thanks. Appreciate you being here and hope you stick around for the last session. So thank you.